Hello and welcome to Do-It-Yourself Musician. What you're looking at right here is my 1986 Amek TAC Scorpion console. This is a 3282 mixing console made by Total Audio Concepts in England. That was a division of Amek. This is a good console for recording and mixing. So far it's been just fantastic. I've been slowly rebuilding it. I'll have some videos on that in the future of rebuilding the actual console. But today I want to take a look at what runs this thing, and that's the power supply. So let me get you a shot of that. Okay, here's a shot of the power supply that runs the console. This is a TAC 750 power supply. This power supply is capable of providing 10 amps of current to the audio section, which runs on plus and minus 17 volts. It can also provide an amp of current in the 48 volt phantom power. This particular unit that you're looking at runs fine. Haven't had any problems with it. I got this off of eBay. It was in great shape. Man, I just checked it over, did a few minor little repairs to it, and it's been running like a champ for over a year now. However, I've only got one of them. And, you know, it's, like I said, it's made in 1986, so these things are getting a bit old. So I wanted to have a backup power supply, which you should have that anyways, no matter how old your console is. You should have a backup to keep it running, so if something happens and the power supply goes down, you don't have to repair it or spend time repairing it. You can just switch over to the other power supply. So what I've done is I've been looking on eBay for a good project power supply at a good price, and one finally came up. So in this video we're going to have a look at repairing that one, and then in a future video we'll probably go ahead and go over this one and give it a complete overhaul as soon as we get the other one running. So let's take a look at the one I just bought off of eBay. Okay, here's a look at the Amek TAC Scorpion power supply that I just got off eBay. I got this to be a backup to the one I have currently. This one, unfortunately, is pretty junked out. That's all, but you know that it was cheap. I was looking for a cheap one to rebuild, and this should be eminently rebuildable. We really shouldn't have a problem with it or have to sink very much money into it. Fingers crossed. And there's also some modifications that we can do to this that are suggested by Column over at Audio Maintenance Limited in the UK, and we'll carry those out because I don't believe this power supply has been modded. As you can see, it's in pretty rough shape. There's a lot of rack rash on it. This fuse holder here came just like this. There was no fuse, no cap, and it was loose. These other two, I undid those. I've already gotten into this. I've taken these screws out and stuff. All that was there, but it was all mismatched hardware. Unfortunately, someone has gotten inside of this thing and messed around. What I want to do today in this first part is we're just going to get in here and just take an inventory and look at some of these components and see what we might need when we go to rebuild this thing, and just generally check the health of some of the components in here. So let me pop the top off of it and get you a closer look. Okay, let's take a look at the layout of this power supply. You have a mains connector here in the back. It flows up to the switch in the front here, and a fuse for the mains fuse. That's a 5 amp mains fuse. Then it goes to this terminal strip, and depending on how you hook up here to the primary side of the transformer, you can operate this on various voltages in different countries. This is where the secondaries come out. On this side, and I've already removed most of these wires because I've pulled this board out here to inspect it already, but on this side is basically the 48 volt phantom power. This is the diode bridge for the phantom power. This is a LM317 linear regulator for the phantom power here. I believe this is a smoothing cap that's on that rail. Here are these three fuse holders here. This is the fuse, the 1 amp fuse for the phantom power. This is the minus 17 volt supply fuse. This is the plus 17 volt supply fuse. I think these are 10 amp fuses. The plus and minus rails are supplied by these LM338Ks in conjunction with this NTE 219 power transistor. These are again adjustable voltage regulators. back here. And then of course you have these 10,000 microfarad bulk smoothing caps, and that's all on the plus minus 17.5 volt rails. And that's basically the components of this. It's pretty simple layout for a power supply. I'm not going to like really get too deep into the schematic. The object today is to just test, make sure everything works, make sure we have the proper output voltages on the transformer, check these caps, check the diodes, check these caps. These are going to get replaced anyway, so I'm probably just going to suck these on out of there. And then we'll want to remove these heat sinks with the power regulators here, because it looks like, I mean, if you can see, it's hard to see from this, but I mean, obviously you can see there's screws missing in here. Someone's already messed around in here multiple times. You can see right here where someone has written in Sharpie what these transistors are. So it's obviously someone's dug around in here to service this before, but whenever they put this back together, I mean, this is like really crooked right here. When I received it, like you can see how much that's moving. You can hear it. This is sliding up and down in its socket. So we're going to pull all of this off of here. I believe that all of these should be in a socket underneath. And it's part of the modifications that AML suggests is that we pull these heat sinks off and remove those sockets and permanently solder these to the PCB. So that's what we'll be doing. And okay, well, let's get started testing some components here. I think the best place to start for this is going to be just go ahead and try to pull this circuit board out of here. I think I need to get this front panel all the way off. I've already got everything loose in here. I just need to take screws out of this front panel. I'm going to need an Allen set to do that. Oh dear. That's not getting. There we go. Okay, let me move this stuff out of the way. Okay, I wanted to test this transformer before we went too far, because if this thing isn't working, then there's no point in continuing with this project at all. And I did notice when I got this that this plate in the transformer itself is loose. I mean, this thing has been bumping around a little bit in here, which is not good. So I'll have to look at this later and tighten this up. But anyways, what I've got set up here basically is a bunch of meters here to check the AC voltages on the secondaries. And if you look at the schematic here, you'll see that we have a 20 volt AC there, a 20 volt AC there, and then a 40 volt for the phantom power supply. So basically these are your two audio rails, and this is for your phantom there. And the way I've got it set up here is this is going to be measuring the 40 volt rail, and each of these two are going to be measuring the two 20 volt rails, and the Tenma back here is going to be measuring the voltage coming out of the variac. And I'm going to go ahead and switch on the variac and start dialing it up, and we'll see if this thing wakes up. So if you just watch the Tenma back there, you can see bringing some voltage on now. Just going up real slow. And everything seems to be coming up fairly consistently, so about 30 volts now. So we'll go on up to like let's just go up to about half. All right, there's 60 volts. That's about half. Everything really seems to be coming up like you would expect. We got 24 volts on our 40 volt rail, and our two 20 volts are very close. So I'm going to go on up. I'm just going to say right now that this thing is probably working fine. It really looks like it is. I don't see anything smoking. And also keep in mind too that this is unloaded. I'm just directly across the secondaries. It's about 100 volts there. Coming on up to 120. Just try to get to settle out there on 120. All right, there's full 120 line voltage right there. Got 47 on the phantom power rail and 23 on both of the audio supply rails. So that looks good to me. And like I said, keep in mind these are unloaded voltages. If you can see, I'm just clipped here right across the secondaries in this. So this all looks really, really good. Looks like that transformer is working. So let's go look and see what components we're going to need to get for this thing. Okay, let's take a little bit closer look at this main PCB and some of the components on it. Of course, you have your big reservoir caps back here. And there's various little electrolytics spread around. Looks like a couple of maybe tantalums there, I believe. Here's your LEDs for the front panel indicators on this side. And if you look closely here, you can see, I don't know if we can get in there and see this, but yeah. I don't know what in hell is happening. Oops, sorry, it's hard to point there. This looks like some kind of hack job. That doesn't look right at all. I don't know what the hell that is. I mean, that might be factory, but I don't think it is. Yeah, let's take a look at the bottom of this. And that looks like shit. Oh my God. There's some horrible, look at that. That's some horrible hack job shit right there. Wow. And even over here, look at this one. Like, it looks like the traces are lifting up. The main caps look okay. I'm not sure what that crap is, but solder joints look all right. Those might be factory. I'm not sure, but someone's definitely messed around with the transistors in this, and whatever the heck they did with these wires over here. I think, did that prevent them maybe from screwing this down? Something is not good here, though. Okay. Well, I guess the good news would be that the modifications in AML's document for this will remedy all of that. It looks like I might have some trouble getting all this out of here and preserving the traces, though. I think, since I'm doing a complete rebuild on this, I think what I want to do with this right now is we're going to, first of all, suck out these main caps. And we'll take a look at those after we get them out of circuit. And these caps are five pins in this weird pin spacing arrangement. It's kind of, I don't even know, like, what do you call that? It's very strange. But only 2 of these are actually connected. It looks like it's going to be that and that. The rest of them are just on there for stability and strength. So if we can't find a 5-pin variant, we might be able to find one with this 2-pin spacing or something. So let's go ahead and just fire up the desoldering gun, and let's just suck out these main filter caps. There you go. This is a Philips 10,000 microfarads at 40 volts. And there's that weird pin arrangement. And hopefully maybe one of these part numbers we can get to cross over. So let me go ahead and get the rest of these out of here, and then we'll do an ESR test on them. Okay, I've got all these caps pulled out of here. And just for shits and grins, let's test them all. Here, I'm sure they're probably all going to be fine. And I think that we were on 1 and 5 are the pins that are being used, so 0.02, 0.02, 0.03 on that one. And the last one, another 0.02. All right. And I figured they would be good. I mean, this thing might have been recapped at some point. I'm not sure what the stock caps were in it, but anyways, I don't care in this situation because I want this power supply to be as reliable as it can be. So this is going to be a complete rebuild, which means these caps here are going to get replaced. All right, so I'm going to have to hold this on the back side and unscrew it from the front, which is basically impossible to get on video. This is what happens when you try to be a YouTuber. I can't. Let me pull the rest of those out. It's going to be so awkward to do it on camera. Let me get those out of there. So I'm going to take it that that's an example of what's wrong with these sockets. Here, I'm actually going to have to unscrew these to get the thing separated from the socket. Okay, I've got this 219 unscrewed. All right, good, yeah, it lifted out of there. But, I mean, you can see here, this is the problems that they're talking about with these sockets. That's the pin, or I don't know what you call it. That's the little part of the socket that the pin plugs into there. That socket is just destroyed underneath there. And let me pull this other transistor off and I can show you that. Okay, there's that transistor out, and yeah, another little socket came off on this one too. And now I should be able to, this is not going to come off, but it should come over more. No, I guess it will come off. That's heatsink. But yeah, look at these, this space here. Yeah, look at these sockets. I mean, they've completely pulled out. Here's the pins where it's soldered on the backside there. They're still in there. It's completely broken away. Same on this one. You can see it right here. But yeah, that's the modifications that AML recommends on these things, is to get rid of these sockets because of this very problem, which obviously this unit was plagued with that. And hopefully we're going to remedy that whole situation and rebuild this whole thing. All right, let me pull out the other transistors and heatsink. Okay, let's try to pull these ones out and get those oscillation pads out of there too. Yeah, this one's a lot more firm than the other one was. I don't think it's so broken down. There's the heat sink. Yeah, whoop. So yeah, here we go. These feel much better. They seem to be in there a little bit better. Not like these ones, which are complete trash. So I think the next thing I want to do is just try to get these sockets out of here. Some very sketchy soldering going on back here. Just be real careful not to lift any traces or anything. Alright, well I got all those junky ass old TO3 sockets out of there. I mean, it's just, just look at that. Like it's hard to tell even what a pad might be. I mean, it looks like there's a pad here possibly, but then there's like scraped off all around. Maybe they were trying to get to the copper or something. I don't know. I just hacked them out of there. Just gonna have to clean all this up with some flux and solder braid and just try to get it cleaned up more. That's just absolutely ridiculous. Whoever worked on this. I mean, you can see also, like, I mean, look at this connector down here. Like, look at this crap. What the hell? I mean, is it just someone in here with a screwdriver? Just, oh dear. Here's the top side, you can see. But you know, I mean, despite all the problems that this board has, it's still fixable. I mean, we have a good PCB, and you can see there's not a lot of components to this thing. Okay, this transistor here is an NTE197. That's a PNP transistor. Here's a pinout of it from the data sheet. Okay, here is it's going to be the emitter. And to base, we have the, that should be seeing a voltage drop there. Huh. Okay. Let's go collector base. All right. Let's check this. Oh boy. Well, that's no good. That's shorted. That's interesting. What do we have here? Oh god, there's so much shit on there. .5 ohm. 0. Okay, I went ahead and sucked that guy out of there because across it I've got these, like, I don't know, these are like 1 ohm wire round resistors or something. And so I think it's making this look like a short just to be sure. So I was going to pull this out of here and see what we read. Yeah, see now we're, yeah, see now it's reading good. So it's probably these guys that was causing it to look like a short. Okay, this is the NTE 219. It's a PNP transistor, so I should get a drop across here. Yep, and I believe across there. Yeah. Okay, that one looks good. All right, let's take a look at this diode bridge that's on the Phantom power rail. Let's just check. We should have a diode across here. Yep. Then we should have one across here. Yep. And I should have one here. Yep. And then I should have one across here. Yep. There we go. Okay, so this is the inside back of the case, and you have these two big power diode bridges back here. I think these said they were rated up to like 18 amps of current on them. This is your 220 volt AC secondaries coming down to be rectified here. So we just want to check these out and see if we're getting a reading on them. And it's going to be kind of awkward to get in here, but I'll do my best. So we should have a diode drop there. Excuse me, there. Should be a diode drop. Then we should have one here. Yep. And we should have a diode drop there. And one there. Okay. Maybe like that. So we should have a diode drop here. Yeah. We should have one here. Somewhere here. Yeah, there. And I should have one here. And then another here. Yeah. All right, that looks good. Looks like those are good too. These actually don't have a part number on them, so I don't know what these are. I took one out already and looked at it. I don't actually know what part that is. If anybody knows, let me know. Okay, I just want to take a moment to look at a few of the parts that we're going to use to rebuild this power supply, some of which I've already got in stock here. First of all, let's take a look at the small electrolytic caps that I'm choosing to use. This is the ones, they're these Worth Electronics WCAP-ATG5. These have been out a little while, being sold by Mauser and DigiKey. I've never used these particular caps, but I thought why not give it a try. These are a good 105 degree C rated general purpose electrolytic. And as you can see, I've already got some of these in. This is the 10 microfarads. And we have 10 microfarads at 63 volts. Closer look at those. 10 microfarads at 63 volts on there. And we have 10 microfarads also at 50 volts that I'm going to be using to replace the tantalums on there. We're just going to, you could use your 10 microfarad at 63 volt and just use one part number, but I went ahead and bought both just to replace the tantalums. And also 2.2 microfarad, 63 volts also. And this was a good line of caps because they had all of everything in the 63 volt rating, which not everybody seems to have. For the big axial cap that's on the 40 volt rail there, this is what I chose to use. It's the Vishay BC138 AML. You can kind of see the ratings on that there. And here's the actual cap here. I've already got this one in too. And there's the part number I ordered. And again, I'll put a list of these down in the comments below, all of the parts you need to basically rebuild one of these power supplies. And the big filter caps, I'm going to talk about this in just a minute. But first I want to talk about the transistors that we have in here. The LM338s, the NTE219, etc. that's in the unit. On this particular unit, those seem to be working, so I'm not going to worry about replacing those right now because they still should be good. But you could, I'm sure, find replacements for that easily. On my units, I do have bad fuse holders. There's a couple of them that are messed up. I was not able to find these fuse holders in the past until I pulled this one out of the unit we're repairing and noticed this RS logo on here. And with that, I was able to figure out that this fuse holder is made by a company called Schurter. And it's a Schurter FEU. And it turns out that Mauser and other places actually do carry the Schurter FEU. And they also carry it with this peculiar sort of 5-point star cap on it. I think they call this like the finger grip cap or something. And this is made for the 6.3 by 36 fuses. You can see here. There it is. So that's, I mean, that's virtually, not virtually, it is the same as the ones that are used on the units. I mean, it's exactly the same thing. So I'm glad I was able to find those so I can make those original. And even repair the current power supply that I'm using on my console right now is actually missing one of these, and I'll be able to fix it. Part numbers on those are, there's the fuse holder. That's the FEU, and it'll hold 5 by 20 and the 6.3 by 36 fuses. It just depends on which carrier you have. And here's the part number for the carrier, 6.3 by 32, and that is this style, the finger grip style on there. And of course you get the nuts for it too. Now on to the big filter caps in this thing. This is the one I pulled out of the unit we're working on. And this is the part number right here, this 222 number. All you have to do is replace the first 3 2s with MAL. So MAL to 050-57103. That's actually a current part number. It's available now. It's current stock anyways. Here is the data sheet on that, the 050 series PED PW. These caps are 15,000 hours at 85C. It's hard to find a big capacitor like this rated at 105. Typically, if you do, they have either low hour ratings or they have way too much ripple current in them. So, but these should be good at that kind of rating. Yeah, these are really good caps. The problem with this capacitor, even though it is current, as of the time I'm making this video in the United States, I cannot find these capacitors for sale. I have found them for sale from European sources, but only if I buy like 30 of them or something, or bulk quantities, which I can't do. I only need 8 of these things, and they're, depending on the seller, they can be pretty pricey. These can be anywhere from like $5 to $20-something. There is a different version of this right here. This is the 051. This one is available to me right at the time as I'm making this video. This cap I think is not as good as the 050 cap. It has less hour rating on it, life rating at 12,000 instead of 15,000, and the ripple current is higher. So I was able to find a different version of this for sale from a different manufacturer, and that's this one. This is the Kemet. It's the ALP 20A103DD040. This one is currently for sale at a lot more places However, again, I could not find this in stock in the United States at the time I'm making this video, but this is available more widely. I believe Mauser is going to get a small quantity of these in about a month from now. But I went ahead and looked on eBay and I found a seller that had these for really cheap. They're only $3 a piece. Unfortunately, that seller was, I think, maybe in Lithuania, which is not typically something I would do, but I don't know. I think the caps are going to get here quicker that way, and that was really the only place I could find it that would sell me 8 of these and not 30 of them. I think RS Components wanted to sell these in a bag of 36 or something. Anyway, so I went ahead and ordered those. Those are coming. They'll be here in a couple weeks. So yeah, that's basically the last component I need to get this whole job finished. And like I said, a couple weeks, and I guess we'll have to do part 2 of this video, and we'll do the modifications and reassemble the unit and check it out. Hopefully it works. Thanks for watching.